say expertise started from the biodiversity, then to aquaculture, to aquaponics, and then so she is more, you can say, aquaponics in more interested in aquaponics. That is why we have invited her to deliver the lecture on aquaponics.
Okay, so as sir has introduced, so I am By Rameashvari now from Livelihood University, and I actually work in the FRM division. I mean, like FRM related work. We don't have a FRM division. It's a traditional university. So I am from the Department of Zoology, but working in fisheries. So I work in fishery sectors in the northeast, whole northeast India, and of course the Himalayan, belt, which I'm interested in. And I work in a lot of projects related with biodiversity conservation, and of course related with taxonomy, exploring new fishes and describing new fishes also. It's one of my expertise in the area. And I'm also going around now with sustainable agriculture, in a German, like corporation-related, project where we are working on sustainable utilization of natural aquatic resources in Northeast India, and that is related with the core states, and of course Manipur is also included. That's why I'm one of the team leader in that. But yeah, aquaponics is something, apart from that expertise, like now I'm diversifying to agriculture because we need to have some applied, deliverables related with the society thing and the livelihood related things. And of course, that our youth, the government cannot provide 100% placement, even though we are like educated, but so we need to have some, like entrepreneurship. So, so that they have some entrepreneurship, skill development and all those. And of course, aquaponics is a topic which I was very new to it. And my husband, my advantage was my husband. He's a chemist actually. He did his PhD in chemistry, and he's a theoretical chemist. But he worked in Australia and Israel and all, and he has seen a lot of, technologies which has been developed related to aquaculture, and he was more, motivating me to go into such kind of, people-related and livelihood-related work. So I'm diversifying my field. So now I am coming into aquaponics also. And we actually developed a system. Like we are so much interested in aquaponics that we developed a system at home first. Then after that, we tried it, research based and everything. Then it became successful. Then after that, we developed again a prototype in the university. There was no project, in India though. To apply a project, we need to have an expertise. It's not like in the US that you have a very good idea, then you are given the accountability of the project and you will get that. But it's nothing like that in India. You need to have some papers in aquaponics, and that time only you will get the project. That is the Indian system. So that was hard for us. So what we did was, since we were more interested, so we put a lot of money from our side and we developed everything. And even in the university also, the system which I have built for the students, it's like I put all of my money there. So that's how we have developed aquaponics there. It's working well, and my students are working on microbiomes of aquaponics, because aquaponics, when we say it's a very big thing, so it can have many components, like starting from the system design, okay, that actually basically has to be done by aquaculture engineering people, but if you don't have the engineering concepts and how the water flows and everything will run, and how is the speed of the the pumps, and how much flow rate you need to provide and all. So it's a little bit of complicated things when it comes to the system design. But we as the biologists, we are more concerned with the fish related, the microbiome related, the plants related issues, right? But of course, most of the designing is done by my husband. So thanks to him, and of course, coming to the talk, aquaponics. So I think, can I have a pointer? You're going to change the slide for me? Yeah, okay, next slide. Yeah. So these are the contents of my talk. I mean, why aquaponics is needed, right? Then what is aquaponics, the first thing, because many people may be new to the term, what is aquaponics? Then why do we need it? And in aquaculture, why do we need this kind of technology? Why the farmers don't need to go with the conventional, open pond aquaculture system? Why we need to come out with this kind of things? Then what is the achievable thing, and whether aquaponics can be done in cold water, I mean like cold climate. Because most of the aquaponics related things which has been established or published is related with the tropical climate, agriculture, warm water aquaponics. But why, whether it can be, applied to cold water, that also we can discuss. And aquaponics is a business model for entrepreneurship development. Okay, so that's the content of my talk. Next slide, please. So yeah, why aquaponics, and why this? Not only aquaponics, why RAS, why biofloc? Okay, so when we look into the problems which is happening in the world, because all research is problem related. What is research? We are trying to research something when there is a lot of problem and we have to come up with a solution for the world. So that time, no, we are going for those kind of research, right? If we are going for basic research, it's natural research, it's like naturally thing, okay. But most of the research now is based on problem solving. What is happening in the world? What kind of problem is there? So now the world is having a problem of, like water scarcity, food scarcity, energy scarcity. So this three, things is having a nexus. It's having a relationship. So how we're going to solve that? That is also one key point of aquaponics. Because aquaponics is nothing. When we come to the next slide, we will know what is it, okay? So the global water, food, energy nexus, and sustainability, and also the circular economy. So we can see that this is from the Wageningen report, which was published in 2015-17, that the world population in 2050 will be almost 70%, urban dwellers. So when you have to convert it into urban dwellers, means what? Agricultural land turning into cities, right? Yeah, then of course, what about the water then? If there is an increase in population, consumption of water, then of course the food demand will increase, right? So when the agricultural land has depleted, when there can't be any horizontal expansion, then how can we go for the more food production?
Vertical production.
So we need to go for a vertical production. So vertical production system is, one of them is also aquaponics, okay. So we need to go with those kind of technology. And you can see that we know that the water coverage of the earth is like so much, but only 2.5% is like fresh water. So how do we use that? Because we can't, do agriculture in salt water for the fresh water, right? Except for the marine fishes. So that is the difficulty we have. So these are the things which has been published in the Wageningen report, that because of the increase in population, there will be demand in food, and if there is a demand and more demand in food and consumption, then more demand on the energy for the production of food and all. But you know that the fossil fuels, when they are formed, it takes millions of years, right? Yeah. But when we are depleting it, how many years we are depleting it? In just like few years, like we're depleting all the fossil fuels, right? So how we have to change this from the fossil fuel to what? The the renewable energy sources and all those, right? So these are the things people are worried on, and most of the research now in the world is based on water, food, energy, and apart from what? Apart from the health sector. So health, food, energy. These are the sectors. Yeah. People are working on in all over the world what to do. So this is how we should, and of course India, it's more than how many billion people, right? We have, and so many mouths to feed, but very little, things we are producing. So, and of course India is an agrarian economy where we depend on agriculture. But if our agriculture is more of a conventional agriculture, then we won't be able to meet the demands of the ever-growing population in India, right? So that is the thing. Next slide, please. So when we come to the history of sustainable agriculture, it has started long time, actually. Starting from the Chinapas, the Aztec civilization, which happened in, which was there in Mexico. Then we have in the China, then in floating gardens in different parts of the world. It was there. The principle was there already. Okay. So, but we were not aware of how to make it into a more scientific way. The principle was already there, but how to adopt it in a scientific way. That's how aquaponics came into being, okay? The principle of, sustainable agriculture was there. Then how people have started using these floating gardens. So that principle, we are going to apply it in a more scientific way, and that is the, genesis of aquaponics. Next slide, please. So you can see in Myanmar also they have this floating gardens, then wetland aquaponics, then University of South Wales, Australia. Then we have in Manipur also the Loktak Lake. We have a floating lake. So there is a floating vegetation. On top of that, people start planting vegetables and all. Okay. Next slide. Yeah. So I was going through reports when I have to give a talk to Kashmir. So there we can see that in Dal Lake there was a report on the floating gardens of Dal Lake. I think it's already there, but how do we adopt it in a more scientific way is the thing which is needed now. Okay. Next slide. So yeah, you can see people are collecting these greens from the floating gardens, right? So how we can do the mass production using a more scientific view, that is more important. So this was the report from Kashmir. Next. So coming to the topic aquaponics. So this is actually a two-word which is combined. Aquaponics. Aqua comes from aquaculture. So aquaculture means not only fish, it can be other aquatic organisms, right? It's like soilless culture of plants. Okay. So from that, soilless culture means they were growing plants in water. So that is the ponics. So when we remove the word aqua from aquaculture and ponics from hydroponics, then we combine it and give the term aquaponics. So what is aquaponics then? So there will be aquaculture part, there will be hydroponics part. But in hydroponics, it was culture only in water. Okay. But in aquaponics, we can use other media. It can be sand, it can be gravels, it's not soil, but it can be gravel, sand, or hydrotones we can even buy. In US they use hydrotones, but hydrotones is very expensive for us to be used in India. So we can use the easily available, resources, and we can make aquaponics in such a way that it is low cost for a particular, geoclimatic condition and microclimatic condition. Okay, so that is how we adapt in that way. So aquaculture. So in aquaculture, that in aquaponics we are going to mainly focus on fish. Of course, we can do with other, aquatic organisms, but we are mainly concerned with the fish culture. So in that, you can see in the arrows what is the input and what is the system, food production system. So why is it sustainable? The points are there. Because we are going to use we use the aquaculture water and we are going to make it flow through that hydroponic system. Okay. So the plants will absorb whatever the waste which is there in the aquaculture water. And of course, what does the plants need? Nitrogen, but can they absorb nitrogen like that? No. Okay. So from the fish, of course, when we feed a fish, since most of you are having this aquaculture background, 1/3 of the feed will be taken up by the fish. So the other 2/3 remains, as a waste in the water, as a fecal matter, as the feed which has not been eaten, right? So all the proteinaceous are, when we say proteins, means nitrogenous waste, right? So the nitrogenous waste remains in the aquaculture water. So that water, we cannot just directly pump it to the hydroponic system as I've said here. Of course, we need to take out the solid waste. There is a lot of filtration process that is between the aquaculture unit and the hydroponics unit. Okay, so when the solid waste has been removed, the remaining water, it has to be passed through the hydroponic unit. So what happens in the hydroponic unit is plants, they cannot just take up the nitrogenous waste. It has to be converted into nitrate. Nitrate is a form which the plants can assimilate for their growth and functioning. Okay, so the nitrogenous waste has to be broken down into nitrites and nitrates, right? Then after that the plants will take up and it will help in the growth. So this reuse of waste aquaculture water, then production of chemical-free food without harming the environment. So there is a lot of difference between organic food and chemical-free food. So what is the difference? Because if you go to Europe and other countries, when we can always find a difference between chemical-free food and organic food. Organic food, chemical-free food, according to the US, so they have this definition that there will be no use of any chemical fertilizers, no pesticides, no insecticides, nothing. Okay, so this is what is aquaponics is. So from aquaponics, we will get a food which is having chemical-free. Okay. Then mitigation of pressure on land for the increase of productivity, as I've said earlier, is this a vertical expansion. Then zero carbon technology. This is now the scientists are pushing and trying to say that it is like carbon dioxide is wholly utilized in the system. It's not emitted out. Like in the conventional aquaculture, many aquaculture people doesn't know that, nitrous oxide is released from the ponds. That is the main, the carbon, what? Yeah, so it is leading to the global rise in temperature, okay? So the carbon source here, it will be a zero carbon emission. It will be all absorbed in the system, okay? Then another, creation of circular bioeconomy. This is very important now because the waste from aquaponics, we are letting the plants grow, the first waste, right? So we will be getting the plants from the waste of the fish, right? Then the second waste again can be, we can, collect the gas and we can even make this, biogas plant out of this. The second waste is that. And the third waste, like from the sludge, okay, from the aquaculture, we can, make aeration, we can go for sludge digesters and we can make fertilizers, biofertilizers out of that. So I have tried on that, we have done a research on that and it's coming out very good results. So we are going to make pellets of fertilizers so we can, commercialize the pellets out of that. So it is a very good thing and it doesn't smell anything. It becomes a dark, soil, like a peaty soil. Then if you just put it, then the plants, you can see the difference in the plant growth. So we can see, and we are going for the, mineral content, analysis of all those now in the system, how it is happening and all. So the pellet can be commercialized, and that's what even Israel is doing nowadays. So we need to check, maybe the bacterial component may be different in India because of the climatic conditions. So whatever the bacterial component in Europe may not have the similar composition in India. So we need to check which part is playing the functional role, all those things, okay? So that is the thing, and reduction of use of fossil fuels for food production, okay? So this is why aquaponics is called a sustainable, food production technology. Next slide, please. So, importance of aquaponics. When we see the core value of aquaponics, it can be in relation to food, water, land, environment. As we have discussed earlier also, these are the things. In terms of food, chemical free, then we can go for intensive food production. Okay. Then we can also no environment damage and food security, everything healthy food and chemical free food. The land uses also decreases, and we can even use IoT in all this in aquaponics. Okay, so a lot of things can be done with this. So these is important. Next. So, principle of aquaponics, as I have said, is very simple. You connect the aquaculture system with the hydroponic system. So, main thing, there is a main cycle, symbiotic cycle that is happening in aquaponics if we have to understand the aquaponic system properly. The first one is this fish. Then the second important biotic component is plants. Then the third is the microbes. Without the microbes, it will not. Okay. So what happens is from the fish you get the feed, then the uneaten feed, and also the fishes. Okay. Then that has to be what? Degraded by the bacteria. Okay. So after that, the water, the nitrate, the high nitrate content water has to be released into the hydroponic system where the plants utilize. So even in the plants, when we talk of the microbes, I'm coming up with a book chapter on the microbes of aquaponics, like, all the things. So it will be in a book in Taylor and Francis. So what happens is, like, there is a lot of microbes which is related in aquaponics. In every section, there is a lot of microbes. So what the microbes, like the characterization of the microbes in every system, plus their functional role. That is the emergent roles of microbes in aquaponics. That is what the world is, like, racing towards now. And everyone is researching on what is the functional role of this. And you see, as I've said, according to the temperature and the climatic condition, the microbes also differs. So in India, we are not knowing, like, what are the microbes which is there. Of course, there are some, microbes which are found in all the systems, but there are some particular microbes which will be different in every country. So that we need to find out whether it is having a positive impact on the system, or it is giving a negative impact. That we have to see in the functional role of every microbes. Okay. So that is the thing, and we can see that, as I've explained, it's about using the fish waste and giving it to the hydroponic system and recirculating the water. That is aquaponics. But now, when we say that, then you think that it's very simple, right? But how does it work is also again thing. Now we have to see whether we just need to connect one cycle, or we just need to differentiate the cycles and reconnect again. How we have to do that comes into the problem of system design. So the designer has to think which can be most suitable for a particular place. So when we are setting up an aquaponics, and now you can see that in YouTube, like many of the YouTubers just put the aquaponics system, and many things, and you can just copy an aquaponics system, but your system may fail, right? But you need to see, according to your, conditions, which one is good for you and how you can handle it in a best possible way. Next. Yeah, this is a conceptual diagram of, how a single loop system, there is actually a loop, many loops. The aquaculture loop, the hydroponic loops, both will be connected, so there is one loop. So how we have to do that? That is the systems design problem, okay? So here is a single loop thing. That means, like, from the rearing tank, you send the water to the solid removal, as I've said, then again to the biofilter. So the biofilter is a very important, component in aquaponics, where the microbes activity is taking place in the biofilter. So most of the microbial things will be there in the biofilter. Then again, after the water has been, passed through the biofilter, then it has to go to the hydroponic subsystem. Okay. So in that only you get the, water with rich nitrates. Then after that, when the hydroponic subsystem has totally utilized the water one way, then you can, drain it into a sump, which we call a sump for storing the water. Then from that sump again, it has to be pumped to the rearing tank, where the fish will again utilize. Okay. So this is, the whole, the nutrients has been utilized before you reach the sump. Water has been reutilized. Okay. So this is the single loop. It's run in one loop, so this is called a single loop system. And it was first started by, all this loop system by James Ricocki. Actually, he's a professor in the University of Virgin Islands, and they were the first to design the first aquaponic system. Okay. So next slide, please. Yeah, this is the flood and drain design. So we designed it for the first time like this, and how to design a flood and drain. You just need to flood the grow bed. You can see grow bed is the hydroponic, subsystem. Okay. So the hydroponic system is the grow bed. So from there, you drain it to the fish tank, then again pump it and drain it, then pump it and drain it. So flooding and draining, flooding and draining. So that is there. But this can be done in a different loop also. Like it can be only in a one loop, like grow bed 2, the fish tank. But there may be different loop also now. Like we can go to the grow bed, then again to the sump again, then from the fish tank. So why do we need different loops then? The question arises. We could have done with a single loop, but why do we need different loops? So these are some designs. Next slide, I will tell you. Yeah. So when it comes to the loop system, people said, okay, now it's becoming confusing. So we should explain it in a more, better way. So they come up with the idea of coupling. Okay. So if there is like a single loop, then single couple, a couple. Okay. So how do we couple the loops? If there are two loops, how we are going to connect? Where we are going to connect? Okay. So why this has come is like, because for more optimization, as I said. And another thing is, suppose in an aquaculture system, if your fish is having some diseases, some pathogens, and if the water has to pass through the hydroponic unit, then how will you separate? If it is a single loop, the pathogens will be transferred again to the plants, to the hydroponic unit, right? So in that way, for maximum optimization and efficiency, and to for a more convenient way, then the loop system has developed. Okay. So if we have a decoupled loop, if we decouple the loop, one aquaculture unit, and later it is flowing to the sump, and again another the hydroponic unit. So in that way, what happens is like when the fish is having a disease or plant is having a disease and you need to treat, then you can close the loop. So the water will not pass in the same, section. So it will not go to the other section and it will not pass there. So in that way, you can manage your system well. So in that way, the coupling system has given rise so that people can do it in a better way. Okay. So that is about the coupling. So here it is written, better control of fish and plant components, then more control when the disease and pest outbreaks. Okay. So of course, when you're treating with potassium permanganate or salt, then if you pass the potassium permanganate to the plants, then what will happen to the plants? It will have an adverse effect, right? So you need to close the loop. So that's why the decoupling system is important. So next. So we have multi-loops now. I mean, like in my system, this is like the multi-loop which is given in the books, okay? Under Simon Godek is written a book on aquaponics. So in that it is given like the plant, the hydroponic unit, everything is having a different loop. But now, like in the university, we have a prototype which is having a different loop system again, which I cannot say. Maybe it may be even a patented one. So we are going for IPR for that. So we have come up with different kinds of loop system again. So this is, the aquaponic system is not a stagnant, research now. I mean, it has not reached its height. Anyone can come up with a better idea. So it's evolving. If a farmer has a better knowledge, and if he thinks that the design is more practical, then he can come up with that design. So everyone is like open to that. So we're coming with different designs, so we may adopt that. Again, a better design may come up. So that is the thing that is evolving in aquaponics. Okay. So next. And then the nitrogen cycle is very important, as I've said, because all the nitrogenous waste has to be converted into nitrate so that the plants may assimilate, right? So what are the bacteria which is playing that role? So these bacteria, they may be present in the hydroponic subunit, in the dry zone, root zone, the wet zone, and the effluent zone. So there are different, bacteria which is present in the different zone, and they have a different, functional component. So they will act differently. So on the basis of that, the many bacteria will be characterized in the hydroponic subunit in the aquaculture. Because you see, when you study fish, the gut is also having microbiome, right? The bacteria, right? So the gut microbiota. Then again, the feed microbiota. Then again, the fish on the body itself is also having a microbiota, right? Then so in that rearing component, we already have a big microbiota, right? Then again, in the hydroponic unit, when we see the plant root microbiota, okay? Then when we see the, the gravel or the thing which we are using, they also have some microbiota. So we need to study a lot. And of course, in the biofilter, there is the big microbiota which is related with the nitrification and all those, right? So that is the thing we need to study. So aquaponics, we cannot study the whole aquaponics system. It's a big thing. Someone has to concentrate on some parts. Either you concentrate on the design, system design, or someone has to concentrate on the microbiome, or someone has to concentrate on many things. So it has got its own components. But as an entrepreneur, like development thing, then of course you can go with one design which the expert says, and you have to come up with a business, right? So when we say entrepreneurship means it's more of a profit and business model. So you don't need to know the research part and what. You just need to go with the profit, okay? So that is the thing. And this is the nutrient dynamics and like what happens in the loop system in modern aquaponics. So as I've said, in the hydroponics, the first one is that the input and the outflow. Then after that in the aquaculture, you can see what is the input and the outflow. So when we decouple the aquaponics and connect it together, so what goes in the system? That is the thing that is shown here. But I'll go more into like the entrepreneurship part since it is an MSME training. Next. So these are the like the parameters which is like required in aquaponics for cold water fish, for warm water fish. So what is the optimum temperature, pH? Of course, when we have to go for aquaculture, we need to know we need to be very familiar with the water parameters. Even if it's a biofloc, RAS, or anything, water parameter is the most essential part in aquaculture, right? So temperature, pH, then ammonia, then this total, like nitrates and nitrate, then dissolved oxygen. So these are the main, parameters which we need to know. So this needs to be measured. If you become an entrepreneur in aquaponics also, you need to measure every week or, so that your fish remains healthy. Right? Where is fish reared? It's not a terrestrial animal, right? The environment is water. So if the water condition is bad, how can the fish survive? So the most important thing for a farmer is to know whether the water is good or not. Fish farmer, right? So that is the thing. Then for aquaponics, the ideal parameter, actually that is the conventional aquaponics which people do it in warm water. There has been no, like not much work on cold water aquaponics. That's why we even wrote the book chapter on cold water aquaponics recently. So, so there are some issues related with cold water aquaponics if it has to be done in this region and all. But we can do it. It's not that we can't do, we can do aquaponics, but we need to be a little careful because you have seen that aquaponics is a main, like the parameter which is there in aquaponics is also bacteria. So do you think what kind of bacteria will thrive well in cold water? So the bacteria is going to be different in cold water because all the studies were done on warm water before. And warm water, if there is more bacteria, then more cycles and more efficiency. But if there is cold water, then less bacteria. Only the one which is permitted in that range will be there. So how do we go for that? That is one gap which is there between the warm water aquaponics and cold water aquaponics. Next. Yeah. So there are a variety of fishes which, like we can grow in aquaponics. I mean, like the world has, done research on more than 100 plus fish species, which is an experimental condition also, they won't die that easily, unlike other very delicate fishes. But I have tried in Bangana, Devi also, but they thrive well in my aquaponic system, and even, I was doing with some, labios and all, but they thrive well, but the best is tilapia in the warm water. Why? Because people may not like the, flesh of tilapia, but when it goes, and so they give a lot of fecal matters. So there is a lot of sludge production. So when we have to go, so in that way you have to, design your aquaponics. Whether you want to concentrate on the, production of fish, production of plants, or production of the biocircular economy, which I have, taught. So it's like if you want to produce more, biofertilizers, of course, along with the fish and the plants. And if you are targeting even the production of biofertilizers, then you should go with tilapia, as per our knowledge, because it gives a lot of waste. So in that way, your sludge digester will have more waste, and the sludge will produce, and you can use it in the form of a pellet later on, and go for the commercialization of the pellet fertilizers, right? But if we go for Bangana, because I have tried with Bangana, they produce very little waste. So the fish can be cultured, the plants can be, like planted, and you can grow plants, but when it comes to the production of waste, it is less in Bangana. So an entrepreneur can think before they start a business, like what kind of, things they want to do together. Plant and, fish production will be there, of course, it is an aquaponic system, but what is the waste which you want to utilize for the other circular economy? Okay, so that is the thing. And of course in Northeast, we are fish eaters. We eat all kinds of fish, starting from the small fish to the big fish, right? So when we look at the commercial point of view, tilapia, even though it is not like, people don't prefer much in other inland things, but in Manipur, it is sold at the price of 250 rupees per kg. Okay, so it's more like the carbs only. Then, so if the carbs is growing in 1 year, in conventional aquaculture, you need 1 year for harvesting the carp, right? But in tilapia, in an aquaponic system, we are targeting 3 to 4 months. So in 6 months is the maximum, but we have seen our results in 4 months, even we can, sell. So that is the difference in the time and the growth of the fish, okay? So, and even the anabas, we have a very high price in Manipur, that anabas is sold at 700 rupees per kg. So if you go with anabas, if you are if you are a fish farmer in Manipur, then of course we have to go with high price fish because it's an intensive, aquaculture system. So in that way, how much growth you can achieve, what is the FCR, all those things when we consider, then of course tilapia and anabas, they are much better than the indigenous, fishes. So that is there. So next, yeah, these are the parameters which we need to, maintain in the aquaponic system for different, kinds of fishes. Okay, so we just don't need to go into the details. Yeah, types of vegetables. The vegetables can vary a lot. If the farmer wants to only grow the leafy vegetables, so on the basis of that vegetable also, your aquaponic system design can differ. There is a lot of, difference. We call it a deep water culture. As I've said, soilless culture. When we say hydroponics, we say it's a soilless culture, and we are, planting it in water. So in aquaponics also we can apply the same, aquaculture plus hydroponics. So there is a system called the deep water culture, and there is NFT, nutrient film technology, where we plant it in the water, but we have to supply nutrients in that. So there is a lot of difference in aquaponics and hydroponics. In hydroponics, there is no aquaculture, so the nutrients have to be supplied in the water. So it is a chemical nutrient, so it is not a chemical-free system, okay? And but in aquaponics, as I said, we are going to use only the fish waste as a fertilizer. So we are not putting any chemicals, okay? So that is the thing. Then, depending on the vegetables which you are going to plant, also you can design aquaponic system, okay? It can be NFT, DWC, so for leafy vegetables, but when we plant fruiting vegetables, like, tomatoes, I have grown tomatoes, it grows this big, okay, this big. And cabbages, I've grown cabbages in, gravels, it is like 4.5 kg cabbage, one cabbage, okay. So we showed it in the cow agri fest, and the SIFRI director came and he was like, did you put it from somewhere? I said, no sir, how can we put it? It was grown there, okay. So it's like 4.5 kg cabbage. So that is the, growth. And it is like having a faster growth when we compare it with the normal soil cultures, okay. So the next slide, I'll just wrap fast. So these are the vegetables. Even you can grow zucchinis and many things. Even bananas you can grow in aquaponics. Okay. Then, yeah, and you must have known about the Bhut Jalokia, the king chili. Yes, yeah. So we have grown in our aquaponic system. It started fruiting only in 2 months' time. And the quality of the pepper, the chili, it's like so hot, Yeah, so I was trying to see the mineral content in that, okay. Then next. So yeah, NFT model which I have said. Then yeah, this is the we were trying to make it the low cost aquaponics. We don't need to go with the FRP tanks or like all those things, hi-fi things. So because the farmers cannot afford, we have to think about the initial installation cost also. The farmers cannot, go with a 40, 30 lakhs, installation rate, right? We need to adapt to the resources which is there in a particular place. So what is the best resource you have in your state? That has to be seen, and after that you can make a prototype for the farmers. I mean, if you have to make prototype, no. So we need to come up with an idea which is a low-cost aquaponics. Anyone can say that I'm doing aquaponics, I'm doing aquaponics. What kind of aquaponics you are doing? So that is the main difference. Okay. Next. Yeah. So many techniques we can do. Like we can combine many things. Even if there is no space outside, you can do it inside a room. Container aquaponics, they call it, where they have to use the grow lights, the far red lights, and at what wavelength the plants grow. So even the microgreens in Europe, they are grown inside a container, okay, using these lights. Next. So these are the vertical farmings which is done in many places, even in Japan and all those things. Please, next. Yeah, rooftop farming. Singapore is famous for that. Next. Yeah, next. We'll go, this is the UVI aquaponics, the University of Virgin Islands aquaponics. This was the first aquaponics system which is developed in the world by James Rakocky, and from this the aquaponics has started. So next, you can see, next slide, that aquaponics system was done in 1/8 of an acre, and you can see the production there given. How much fish is produced and how much plants is produced. So in aquaponics, not only the fish you are getting money from, you're getting money from the plants. They say that you get more money even when you harvest more plants. So that is the thing, okay? This is in 1/8 of an acre, how much money you are getting. Next. This is a aquaponics farm in Oman. Okay, so everyone, everywhere, and there is NEOM project which is coming up in Saudi Arabia. So aquaponics can be done in semi-arid, hilly, any areas. So you just need to give the right parameters. Yeah. Next. We have growponics in Bangalore. They are coming up with a farm. But these are all, copied from one design. Okay, this is a business model. I mean, like they just copied and start the farms like that. But we are trying to make it more into a farmer-friendly and more efficient, aquaponics system. Next. So many things are happening. Please, next. These are all pictures. Then I want to come to the real business model before we wrap up. Yeah, this is pent air. And in how many hectares you see they're growing and how much of money they're producing? There is a lot of money in aquaculture, okay, and food production systems. So, because in 2 acres they're producing that much lot of money and that much lot. So, I mean, people when they say agriculture, they think that our hands will be all muddy, our feet will be all muddy. No, you can see how neatly they are doing. You can just go and pluck and eat also in any aquaponics farm in Europe or anywhere. Without even laborers, 1 acre of a farm can be run by using the IoT. So it's easy now. We have to use technology. So this technology has to be given to the farmers so that they understand how to use it. Next. Yeah, this is a golden ratio of aquaponics. This is a draft document which we are coming up with the protocol of aquaponics. I'm coming up with a book on how to run aquaponics, particularly for the starters. Because we have an experience, we have some failures, we have some success trials. So we have to learn from the failures. If you do this, you will fail. If you do this, you will succeed. So with the protocol, then it will be easier for the farmers to understand, right? So we're coming up with the protocols. Yeah, then before you start the aquaponics, you just cannot start the plants and the fish together. There is a rule in aquaponics that there should be the nitrification process that is already happening after that the plant should be introduced. So the fish should be really fast, first, and after that when the bacteria reach certain levels, so 20 days of running the cycle in the fish, after that only you can introduce the plants in the hydroponic unit. That is how the system should start. So many farmers they introduce the plants and the fish together, so it will fail, okay? So that is the thing. Then fit chart of tilapia, if someone has to go with tilapia, so this is just a provided thing. Next, yeah, this is one of the models which we have designed, but we are not following this again. We have adapted another design also. We have followed this, but again we have adapted another design. So we keep on changing the design so that we get to optimize, thing. Yeah, the small scale which we start for our, farmers and students and all. Yeah, the cabbage which I talked about. It's like taken from the soil and you just put it in the gravel. No, it was grown in the gravel. Okay, so it is there. Yeah, this is the taro plant, and this boy is 5 feet 7 inches, but you can see how big the taro grows. Okay, and the stem is so big that sometimes people think this is edible or not. It is very much edible. We eat and we experiment with all those, and we are going with the mineralization content of how different it is from the naturally grown and from the aquaponic system. Okay, next. Yeah, the chilies. We keep on experimenting with many things. So it's like the growth rate is very good in everything. So aquaponics is very good. Next. Gingers also. Remember, it's a rhizome. We thought that it will not be able to grow in the gravel, but it still grows. So we are thinking that in ginger also even grows in that. These are the tilapias which you harvest. Next. So you can see the previous slide, please. You can see in 1,000 liters of water. This is an intensive culture, as I said. 40 kgs of tilapia can be harvested. So in 1,000-liter tank, you can, get 40 kgs of tilapia. So you don't need to get the FRP tank. You can even use a syntax, the water syntax, and rear this for a startup, Yeah, so we were, looking at the internal content of the fish. The FCR we got is 1.25. That was in the early stage. Now we have increased. We have decreased the FCR and all, so it's becoming better. And tilapia is actually, when we look at tilapia, is the most bioaccumulated fish. So it will survive in the most dirtiest water. So when you buy tilapia from outside, you can see that the intestine and everything is so black and muddy. But when we are looking at the tilapia which we got from our system, it's not muddy, it's very white and the flesh is good. Then I went to some of the professors, they took it from me and they're like, your tilapia is so different, we want to buy more. The next. Yeah, this is the financial cohort, how much we need and how much can be earned, incurring how much money from an aquaponic system. Okay. Yeah, this is in a book recently published. So in that we have given en route to aquaponics in cold water, identifying the gaps in principles of system design. Before it was like flow-through system everywhere, okay, but flow-through system has problems with the water management, the quality of the flow rate and all. So because of that, there is a lot of issues. So how do we, tackle the issue in cold water and the flow-through designs? Those are written in that book. Then next, yeah, and this is another one which is coming up in a book which we're going to publish this year. This is about the whole microbiome in aquaponics and the emergent roles and where we can apply. So the microbiota which I have explained. Yeah, so when we come to the fish production in Kashmir, I was just looking up, like your production in 2022 was 25,000 tons only. Okay, but when you have a demand of 1.25 lakh tons. So how much is the gap? You can see the gap in the actual production is 6 times. Okay, so it's 1.25 lakhs, right? So how do you go with that? The production and the demands. Of course, the government has given a lot of money this year, also 176 crores for your fishery sector to build bioflocks and many other areas and all the systems, but I don't know how it's going to happen. So aquaponics can be taken up. First, if someone is not very comfortable, then they can go with the backyard aquaponics first. Then after that, the commercial thing. So the next slide, please. Yeah, this is a slide we have produced. Like lab scale, it can go up to like 5 lakhs. You can build a lab scale, but the micro scale 5 to 10 lakhs. Okay. But when you want to build a commercial, I have built a semi-commercial scale in my home. We have our own, farm kind. So in that we have incurred like 25 lakhs. So people think that 25 lakhs is a huge money for the farmers. Of course, in any new ventures, in any new business, you have to come up with 20 lakhs in India now, right? But when you say it in aquaculture, people think that, oh my God, in aquaculture, 25 lakhs. But if you're buying if you're depositing for a shop in a mall, how much money you need to incur, right? But you're not seeing the money which is coming out from this in just 6 months. So we need to see that also, okay? So there is like crores of rupees will be, needed and spent. And when it comes to the aquaculture production in Kashmir, that 1.25 lakh tons, which is a demand, you are going to pay to other states for importing the demand, which you need, right? You're giving out the money. So why can't you do? Because Kashmir is having a lot of water, resources, a lot of lakes, a lot of reservoirs, which I have seen. Around. I came yesterday only, but I've seen a lot of water things. Even in this university, there is a in that dining room and that guest house, there is a small drain coming up, which is a very fresh water. I was saying that why can't you do the raceway for the trouts here? The small ones. It's just a joke, but a lot of water resource. So why can't you harvest that and harness that and use it for aquaculture, so that you don't need to pay all those money to other states for importing the fish which you require. So that was the thing. So, and this talk is just the superficial one. If someone really wants to go for aquaponics, we need a very detailed planning and a very detailed business model. So yeah, maybe in the future, if someone wants, then they can approach me. Then we can go forward with that. Yeah. Thank you.